Hey everybody. I don't usually have my webcam on, but I figured why not? You don't get to see me every day, so why not do this? Today I'm joined by my daughter Sadie. Sadie, say hi.
Hi.
There she is, calling some pictures. There's Foxy. So if she says she has to go to the bathroom or something, I'm really sorry about that. I got my earbuds and my microphone in. So hopefully that will knock out any of the background noise. A couple things. I have my guided notes here. You should have your guided notes out with you for section 9.7, but if you need to print them off, they're in the link right above the video, so you should see them there. The homework here, page 639 to 640, number 17 to 35 odd. Make sure you show the work. Some of you guys are not showing work, and I was fine with it last time, but I'm not going to be fine with it anymore, so make sure you show your work. All right. So now, I'm going to get my webcam out of there. See you guys. Okay, bye. So sections 9.6, 9.7, 9.8, 9.9. Section 9.7, 9.6 was solving by factoring. Section 9.7 was solving by using square roots. Now, the difference between section 9.6 and 9.7 was, 9.6 was solving quadratics that could be factored. We know now that everything could be factored. So 9.7, 9.8, 9.9 are all about what other methods can you use? So, for example, section 9.7 is about solving by using square roots. It's just a different method of solving quadratics. But you can't always solve by square roots. You can only do them in specific times. Okay, now what is a square root? A square root can be used to solve some of these quadratics. Remember that a square root is something that looks like this. The square root of 9 is positive 3, but it also could be negative 3, right? If you've got the positive or the negative root of negative 3. What I'm asking you here is, like, if I had this equation, x squared is equal to 9. What are the solutions for x? What could I put in for x? Well, I could put in 3. Yeah, 3 squared is 9. But isn't negative 3, if I input negative 3 in, isn't that also 9? So you not only have to consider the positive root, but you also have to consider the negative root. Now, to do that, we have this fancy little symbol that means plus or minus, both considering both the positive and the negative. When you take the square root of a positive, and this is that symbol right there, this one here. Okay. Ooh, should bring my circle down a little bit more. Oh, there we go. All right. So this plus or minus square root of 9, that means it could be both the positive 3 and the negative 3. Okay, that plus or minus sign right there. All right. Okay. Now we use that, and it's read plus or minus 3. Now we use that when we solve square roots. Now, you can only solve quadratics using the square root property that don't have a b term. So I want everybody to write this out here. This is when you have no b term, okay? You don't have a b term. Now remember what that means. It was like ax squared plus bx plus c equals 0, or a, b, and c are all numbers. If you don't have a b term, you can solve by using square roots. So you're just going to have an x squared and then the number, okay? All right, now when you solve the square root, right? When you solve this quadratic here, it's x squared is equal to 15. Notice how, if it was in standard form, it would say x squared plus 0x minus 15 equals 0, right? That bringing the 15 over would give you a minus 15 here. There is no b term. My b term is 0. Okay, that would cancel out. That goes away, leaving you just x squared minus 15 is equal to 0. Add the 15 over to the other side, and then what we can do is solve directly by just, how do I undo the square here? I take the square root of both sides. When you take the square root of both sides, you have to consider both the positive and the negative, which means you're going to put a plus or minus out front. Okay. Now, what does that mean in terms of these equations here? Let's do them. All right. Solve using square roots. We've got x squared is equal to 121. So it's already set up for us. We have x squared on one side, the number on the other. So we take the square root of both sides. We take the square root of x squared, and we take the square root of 121. Okay. Now, when you take the square root, please write the plus or minus symbol in front of it. What happens here is that this will cancel. The square root and the square will cancel, leaving us just the x on the left side. And then we can take the square root of 121. Now, to take a square root on your red calculators, you just hit the square root button and then 121. I'm just going to do it here. 121 This one you have to hit the number 121 and then the square root button. But the square root of 121 is 11. Okay, what does that mean? That means that 11 times 11 is 121. A lot of people might try to tell me that the square root of 121 is whatever 121 divided by 2 is, which is not correct. You're looking for whatever multiplies by itself to get 121. Like 10 times 10 is 100, 9 times 9 is 81. 11 times 11 is 121. So the answers are x is equal to plus or minus 11. Now, remember that is really two different things, right? We don't have to write it out, but this really means that x equals 11 and x equals negative 11. So in our last section where we were always getting two answers, or I shouldn't say always, but a lot of the times getting two answers, we still are getting two answers, but we can just write them as one thing because it's just the plus or the minus of that 11. Okay, let's keep it going here. All right, well, what happens if it's a 0? Well, and just the square root of x squared, and then plus or minus the square root of 0. Now, can 0 be positive or negative? No. So it ends up just being 0. So this is actually an exception where we only get one solution. Okay. Now, what happens when there's a negative on the other side? When there's a negative on the other side and we go to square root of negative, weird things happen. We actually don't fully comprehend this until we get to Algebra 2. But what happens is that there's actually no solutions here. Okay, whenever you square root a negative number, there are no solutions. Okay, there's nothing that you could put in there to make this equation true. Okay, all right, let's keep it moving. If a quadratic equation is not written in the form x squared equals a number, we can use inverse operations to isolate the x squared. So here's what I mean by this. Well, just get x squared alone. Notice again how there's no b term. There's no number, just number times x. So we can solve this by taking square roots. 32 minus 7 is 25, so we could take the square root of 25. The square root of 25 is 5, so it's plus or minus 5. Okay. Let's keep it going. Okay. We add 49 to both sides. So we get 16x squared is equal to 49. And then when we divide by 16, watch what's going to happen here. I'm going to leave it as a fraction. 49 16ths cannot be reduced. Right? The only factors of 49 are 7 and 7, and then 16 does not divide by 7 evenly. So let's try to take the square root and see what happens. Now remember that we take plus or minus square root. Well, what is the square root of 49? The square root of 49 is 7. Don't believe me? 49 square root 7. And then what's the square root of, oops, give me my pen back, please. What's the square root of 16 is 4. So it's x is equal to plus or minus 7/4. Okay. Don't give me a fraction on, or just, sorry, don't give me a decimal on that one. Just give me a fraction. Okay. Same thing here. We divide by 36 to get the x squared alone. So we get x squared is equal to 1 over 36. And then we say x is equal to plus or minus the square root of 1 over 36. Now what happens there? We take the square root of the top and then the square root of the bottom. So the square root of 1 is 1, the square root of 36 is 6. So it's plus or minus 1/6. Okay. Now, when solving quadratic equations by using the square root property here, you may need to find the square root of a number that is not necessarily a perfect square, like 15, for example. In this case, we can just approximate the solution. What does that mean? We can use a decimal. Okay. When it's not a perfect square, you can approximate the decimal. For example, I square root here, and I will get x equals. Now, don't forget the plus or minus. You still need the plus or minus. But what happens here? 15 square root gives me 3.87. 3.87. Let's round it to the nearest hundredth. 3.87. Now, don't lose sight that still is two numbers. That's positive 3.87 and negative 3.87. Ooh, that's a funky 8. There are still two solutions there as well. Okay. Take a look at this one. Get rid of this. Again, first step is to isolate the square root. So we subtract 90 to both sides. Get negative 3x squared is equal to negative 90. We divide by negative 3. we get x squared is equal to positive 30. Now, think about the square roots around 30. 16 still too low. 25, it's close to it, but still too low. And now 36 is the right above it. So it's somewhere in between 5 and 6. Right? 5 would be 25, 6 would be 36. So when I square root this, I'm expecting to see something between 5 and 6. Let's take the square root of 30. 5.47. Somewhere between 5 and 6. 5.48. Rounded to the nearest hundredth. Oop, I almost forgot. Plus or minus. Okay, if you don't write that plus or minus in, I will have to take points off. Let's do a couple more. We would subtract 90 over to the other side, but wait, it's a little bit easier just to add x squared over to the other side. Okay, so that would be an x squared is equal to 90, and then we square root it. Plus or minus the square root of 90, which is, let's see what the square root of 90 is. 90 square root 9.49 plus or minus 9.49. Okay. Again, you can only do this decimal when it's not a perfect square. We subtract 45 over to the other side. And then we have x squared is equal to negative 45. And then we would take the square root of negative 45. Let's see what happens when we put it in our calculator. Some of you guys are like, whoa, no solution because it's negative. Let's see what would happen. If I do negative 40, oops, get out of there. Clear. Negative 45. Oh, I got to do that. That's right. It's a weird calculator. And then I take the square root of it. It says invalid input because I'm trying to take the square root of a negative number. So there are no solutions. Okay, we can write out no solutions. We can give that there. Okay. All right, last problem here. Mrs. Prezada is building a retaining wall along one of their long sides of her rectangular garden. So we got a rectangular garden here. The garden is twice as long as it is wide. So if its width is x, what would the length be? Think about it. This is x. Ooh, 2x, wouldn't it? It also has an area of 578 square feet. Right? So we can say, well, what's the area of any rectangle? It's just length times width, or 2x times x. That's the area. Okay, so what does that mean? That's 2x squared, right? Is equal to 578. We divide by 2 to both sides. Get x squared is equal to 578 divided by 2, 289. Okay, and now when we square root 289, it's 17. Now, we would normally say x is equal to plus or minus 17, right? Okay, but the problem is, can we have a negative length? No. So we throw out the negative, and we say 17 feet. Okay, so x is 17 feet. Let's put that here. I think it wants the length, so just double it. We say 34, I believe 34 feet. Okay. So 17 by 34 foot garden. Okay. All right, I hope you guys are having a good day. Hope everybody's staying happy and healthy. See ya.